So today we're going to cover section 3 of the prerequisite chapter. Today we're going to learn how to add, subtract, and multiply polynomials. So when we add and subtract polynomials, it's like combining like terms. When you have like terms, it has to have exactly the same variable with exactly the same exponent. Once we have like terms, then we just add or subtract the coefficients. So here is an example where we are trying to add two binomials. Now, if it's easier for you to see, you could rewrite the problem and drop the grouping symbols. You don't have to do this. All we're going to do is go back and look for our like terms. So I have a y squared here, and then I have another y squared here. So I'm going to add the coefficients, and in this case, because the signs are different, I'm subtracting. I'm doing 4y squared plus negative 7y squared, and I get negative 3y squared. Then I'm going to go back and look for more like terms. I have a negative 3 and a positive 9, and that gives me positive 6. And I'm done. Generally, the way I'm going to be writing my answers is I'm going to be writing them in standard form. And standard form is I would write the biggest exponent first, and then I'd go down and do least to greatest to least, and then write the constant at the end. However, technically, 6 minus 3y squared is also an acceptable answer. However, generally, you're going to see it written that way. But technically, either one of these is correct. Let's try the next one. Now again, you can rewrite it like I did, or leave the grouping symbols and just go through and look for your like terms. So I have a 5x cubed. On this one, I assume it's got a 1, so a 1x cubed. I will add those. Then I'm going to go back, look for any x squareds that I have. Negative 7 plus 2 is negative 5, x squared. Notice when we combine like terms, we are not adding exponents. We're only adding or subtracting the coefficients. Next, I'm going to go back and see if there's any x's. And I have a negative 1x here. And now I'll go back and get my coefficients, or my constants. Negative 3 plus 8, and that gives me 5. And I'm done. Now, for subtracting polynomials, I like to do keep, flip, change, or you could also call it stay, change, change. Essentially, what we need to do on number 3 is this subtraction sign that's in between here needs to distribute to all of these. So what I like to do is I keep my first polynomial the same. I change the sign that's in between here to a plus sign, and then I change all of the signs in the second polynomial to opposite of what they are. So I either think of this as a stay, change, change, or a keep, change, flip, however you want to think of it. Just remember that you're subtracting all of the terms. So now I'll go back and I can look for like terms. If it's better and you need to rewrite it, it becomes 2x squared plus 1. You keep that one. Then this is a minus x squared plus 2x, and then the minus 1. Now I can go back and look for like terms. I have a 2x squared, and then a negative x squared. 2 minus 1 is just x squared. Then I can go back and get my x's, which is positive 2x. And then notice 1 minus 1 is 0, so I'm finished. Try another one. Same thing, we're still just subtracting. Again, I'm going to do my keep, flip, change. So I'm going to change this sign in the middle to a plus sign, and then I'm making all of these opposite signs. And again, if it's easier for you to see to rewrite, go ahead and keep the first polynomial the same, and now rewrite how you changed all the signs in the second one. The reason why I do this is everybody always remembers to subtract this first one, but then students tend to forget about the other ones behind it. Now that I have all my correct signs here, now I can go back and add my like terms. This becomes a 4x to the fourth. I'm going to look for any x cubes. I don't have any. I do have an x to the x squared and an x squared. Assume a 1 here. So this becomes 3x squared. Then I'll go back and get any x's that I have. And this gives me negative 7x. And then I don't have anything to add to this 2, so I just rewrite it. Again, my first one should be a 4. This should be a 4. So again, I'm writing my answers from greatest to least of exponents. However, technically you could write it in any order. The next one, notice there are parentheses and brackets. I'm going to work within the brackets first. So I'm going to simplify everything in here, combine the like terms, then I'll subtract. So over here, notice the only thing in these brackets that I can combine are the constants. So in the bracket, it's going to become y squared plus 3y minus 6. Let me rewrite the beginning. And I'm subtracting again. So again, I'm going to do my keep, flip, change. Make this a plus sign, negative, negative, positive. Now go back and look for like terms. There is nothing to add to the y cubed. So let me just write it down. Next, I'm going to look for any y squareds, and I have this one, nothing to combine with it. Then I'll look for my y's, nothing to combine, rewrite it. And again, only thing I can combine here are my constants, and I get plus 7. By doing the keep, flip, change, on any of these terms that there was nothing to combine with, then when you write your answer, it's got the correct sign on it. Next, we're going to move on to multiplying polynomials. Pretty good on this example. Okay, next, when you multiply polynomials, you're going to multiply the coefficients, and when you have variables, you're going to that have exponents, you're going to add the exponents if that variable base is the same. When we multiply two binomials, we can either apply the distributive property or we could apply FOIL. After we FOIL or distribute, then we look for like terms to combine. And we'll do some examples. We'll first start out with just applying distributive property. Pretty good on this slide. All right, let's try some examples of multiplication. So number 6, all I need to do here is distribute the x to the 3x squared, and it becomes 3x cubed. Then I'm going to distribute the x to the negative x, becomes negative x squared. And then lastly, the x to the 1, and it's plus x. And I'm done. Going to do the same thing on the next one. I'm going to distribute negative 3x to 5x and get negative 15x squared. Distribute it to the 2 and get negative 6x. Number 8 is the same thing. I'm just distributing it to a trinomial now. Notice there's 3 terms I need to distribute it to. Y squared is going to go to the 4y squared, and it becomes 4y to the 4th. Then I'll distribute it to the 2y. And then lastly, to the -3. And again, becomes -3y squared. Same thing, even though it looks like it's written backwards, you could either think of it going this way or move it to the front, but it really doesn't matter. You're still doing the same thing. So I'm going to distribute the 2 to the 2y to the 3rd, and then I'm going to distribute the -3y also to the 2y to the 3rd. Now notice this time my exponents are least to greatest. You can leave it this way, or if you'd prefer, you could flip it around and put the 6y to the 4th first, and then the 4y to the 3rd second. It doesn't matter. Either way is acceptable. Next, we're going to FOIL. We really already did this when we did the radicals, but now no square roots or anything. We're just going to be multiplying variables and numbers. So try number 10. So I am going to either, you can think FOIL, or you can just think distributive property. So I'm going to do first, you use the FOIL technique. This gives you x squared. Then I'm going to do the outer numbers, or the outside. Then I'm going to do the inside. And then I'm going to combine my then I'm going to do last and get -32. So this is last, this is in, this is out. When you FOIL, you'll be able to combine your like terms in the center, the outer and the inner, and the final answer here is x squared minus 4x minus 32. Let's try number 11. Same thing. I'm going to do first and get 15x squared. I'm going to do the outside, 21x. Inside, -10x. And last will give me -14. Again, you're going to combine your two middle terms. Final answer, 15x squared plus 11x minus 14. The last two examples on this page are the same. We're still FOILing or distributing. So again, first gives me 2x squared. Outside gives me 10x. Inside gives me -4x. And last gives me -20. Again, combine your middle terms, gives me positive 6x minus 20. Last one, first is 28x squared, the outside, -21x, inside, -8x, and last, positive 6. Combine your middles, and you end up with 28x squared minus 29x plus 6. And you're done. So the next, we're going to multiply two trinomials. No trick here. We're just doing distributive property. Now, what I like to do is, instead of putting your answer all on one continuous line, as I shift to the next number, I make a new line, and I'll show you how I do this. But again, you can put your answer all on one straight line and then go back and combine like terms. The way that I'm going to do it is my like terms are going to be lined up vertically, and then it'll be easier to add. So I'm going to first distribute the x squared to all three things. So this will become x to the fourth plus 2x to the third plus 2x squared. Next, I'm going to distribute this negative 2x, again, to all three things. Now, you could keep writing your answer here, but instead of writing it all continuous here, I'm going to line them up. So once I distribute that, I get a negative 2x cubed. Notice how now I'm lining up my like terms. It makes it easier in the end. Then when I distribute the negative 2 to the 2x, I get negative 4x squared. And then when I do the negative 2x to the 2, I get negative 4x. Next, I have to distribute the positive 2 to all three terms. And again, I'm going to start a new line. So 2 times x squared, notice now I'm lining it underneath the x squared, and then plus 4x, and then plus 4. Now, all I have to do is add up and down. So nothing to add with the x to the fourth, bring it straight down. Notice this one, these are gone. 2x cubed minus 2x cubed, you don't write anything in the answer. Over here, same thing. 2x squared minus 4x squared plus 2x squared, this one's also gone. And then same thing here, negative 4x plus 4x, it's gone. So the only thing left in my answer is plus 4. So the final answer here is x squared plus 4. Now the next one, everything's not going to cancel out. I'm still going to distribute. So the two...
Wait, wouldn't it be x to the fourth plus 4, or would it be
Oh,
x squared?
yes, thank you. Why did I write a 2? Thank you very much. X to the fourth, x to the fourth. Good catch. Yeah, you bring that straight down. Next one, I'm going to distribute this to all three of these. So this becomes 2x to the fourth plus 6x to the third plus 4x squared. Now I'm going to shift, and this one gets multiplied to all three. And again, I'm going to shift it over so it's lined up. And then lastly, the 4 to all three. And again, I'm going to line them up. So 4x squared plus 12x plus 8. Now, if you were to prefer to have written this yellow line up here and the green line up there instead of lining them up, that's also another way to do this. All right, so let's go ahead and add our like terms. Becomes 2x to the fourth plus 5x cubed plus 5x squared plus 10x plus 8. This time, nothing canceled out. I actually ended up getting everything back in, all the variables. All right, on the next slide, these are going to be special products that we're going to talk about. Now, for some students, they're good at memorizing patterns. This first pattern is called the difference of two squares. And notice in between here is a subtraction sign. That's why it's called the difference. There's no such thing as the sum of two squares. We're going to see that when we get to the factoring lesson. This is actually a binomial squared, both of these. And these are binomials cubed. So some students like to memorize the patterns. Again, you don't have to, you could just FOIL or distribute. These cubes, we could also use Pascal's triangle. But it's beneficial if you memorize the patterns. So let's try some examples of these special products. So if you notice, all of the numbers here are the same. What's different is the first one has an addition sign and the second one has a subtraction sign. This is actually going to produce the difference of two squares. But if you don't realize that, you can FOIL or distribute the whole thing, but your outer and inner terms are going to cancel. So if I go ahead and FOIL or distribute, I get 4x squared minus 6x plus 6x minus 9. Notice when I go back to combine these two terms, they're gone. So final answer here is 4x squared minus 9. Again, this is that special product, and it's the difference of two squares. The next one is the same thing. Notice that they both have a 4a, they both have a 5b, but one has an addition and one's a subtraction. So again, this would end up being, if you realize this, just do first and last to get your answer. But I'm going to go ahead and do the whole FOIL just to show you that outer and inner cancel. So I would get 16a squared minus 20ab plus 20ab minus 25b squared. So the 25b squared is from last, and the 16a squared is from first. Notice outer and inner cancel. So the final answer here is 16a squared minus 25b squared. These are both perfect squares. And again, it's got a subtraction sign. So it's called the difference of two squares. Now, this next question, when everybody takes their first quiz, many students get this wrong because they think that they can just put the 2, the exponent of 2, on both of these. Remember, this is a special product and it's a binomial squared. If you just put the 2 on the 6x and the 5, you're going to miss out on the middle term. So one way maybe to avoid this is either to memorize the pattern or write this twice and FOIL it. So 6x times 6x is 36x squared. 6x times negative 5 is negative 30x. Same thing in the inside. And then last gives you positive 25. Notice you have middle terms to add here. They do not cancel this time. Final answer here, 36x squared minus 60x plus 25. Many students will get this wrong on Friday when you take this quiz. So just be careful. You need to FOIL or memorize the pattern. Now, a trick that I like to do on this one.
Miss Corey,
Yes.
this screen, your iPad screen isn't showing.
All right, how about now?
Yeah, it's good.
All right, thank you. Thank you for letting me know. All right, everybody good? All right, so my trick here, if you don't want to write it 2 times and FOIL it, is you can square the first term and get 36x squared. The middle term, I multiply this times this times 2. And then that gives me the negative 60x. And then the last term, I just square that and I get the positive 25. That's a little trick I do with it. But again, sometimes students forget tricks or go back and memorize the pattern. The pattern is this times 2 to get the middle term. Okay, let's try the next one. We could try it with the trick. Square this, and it's 25. Square this, and it's positive 64, x squared. And then the middle term, we multiply 5 times negative 8x times 2. And that'll give me my negative 80x. But if you don't like the trick, you're going to write 5 minus 8x, 5 minus 8x, and FOIL it. 25 minus 40x minus 40x plus 64x squared. Combine the middles, and you're done. Now, if you want to write it in standard form, put the x squared first, and then the 25 at the end. I would accept either answer here. Next one, same thing. We can either do the trick or write it 2 times and FOIL it. So you can either do this and FOIL it or use my trick. 64x squared when I do first. Outside gives me 24x, inside gives me 24x, and then positive 9. Add the middles. Final answer, 48x plus 9. Okay, skip over these for right now. I'm going to go back, and if there's time at the end, I'll work them out. Otherwise, I will cover those tomorrow. So if you encounter any cubes on the homework tonight, you can skip over them. One way that you could do this is you could write this 3 times, FOIL the first 2, and then distribute it, the answer you get with the third one. But I'm going to show you a pattern to this to make it a little bit easier. But this is one way you can do it. So if you want to do it this way, do these 2 first, get your answer, and then distribute it with that. But there is a pattern to it. You can go back to that pattern page. Let's go on and do the last. So again, this looks like would produce, well, notice these aren't the same. This is to the third and this is squared. So on this one, I'm just FOILing. So multiply here, you would get 9a to the 5th. Over here, 12a squared b squared. The inside gives me negative 12a cubed b squared. And then last gives me negative 16b to the 4th. Now, notice these 2 middle ones. These are not like terms, so you can't combine them. This has an a cubed, this has an a squared. So this is the final answer here. 24. I'm going to FOIL these 2. Now notice this is going to produce the difference of 2 squares. But let's go ahead and we could do the whole thing. X squared minus xy plus xy minus y squared. Now notice on this one, when I did these and this looks like it might give a product of yx, and then this one looks like it might be xy. I always write my variables in ABC order. It makes it easier to see like terms. So then notice these are the same. One's negative, one's positive. It cancels. So this ends up being x squared minus y squared. And now I can FOIL it with this one. Again, that middle term is going to cancel. So again, really all I'm doing here is first and last, but just to show you, you're going to do x to the fourth plus x squared y squared. The inside gives me negative x squared y squared. And then last gives me negative y to the fourth. These cancel. So final answer here is x to the fourth minus y to the fourth. If you recognize the difference of two squares, know that you don't need to do the whole thing. You don't need to FOIL everything because that outer and inner will cancel. But if you're unsure, just FOIL it and then you'll see it cancels. Yes.
Can you go back to 23?
23? Yes. All right, we'll just do the last subtraction problem, and then tomorrow I will do those two cube questions.
Okay, thank you.
You're welcome. Everybody good on 23 and 24? All right, let's go to 25. So this one, it's not written as a problem with a plus sign or a minus sign. It's got words. So we're subtracting this one from this one. So this one's going to go on top. So I'm going to write 2x to the fourth minus 10x to the third minus 4x, and I'm subtracting. So then negative 7x to the fourth plus 5x squared minus 1. Again, I'm going to do my keep, flip, change. I'm keeping this one the same, and I'm going to do plus, flip, flip, flip. Now I can combine my like terms. 2x to the fourth plus 7x to the fourth is 9x to the fourth. There's nothing to add with the negative 10x cubed. Nothing to combine with the negative 5x squared. Nothing to combine with the negative 4x. But I do have like term, no I don't, just a plus 1. So there was only thing that was like was the x to the fourth. So by doing that keep, flip, change, it makes sure that I get the correct signs on what I'm subtracting. All right, so turn in these notes. You don't need to worry about filling in the two cube questions. I will work those out tomorrow, and we're not going to turn it in again. Okay, tomorrow we're also going to review for the quiz. The quiz will cover P2, all of it, P2A, B, and C, plus this lesson now, P3. So quiz on Friday is P2 and P3. Pretty good? If you can't open the homework, send me an email so I can email it to you, or you could always ask a friend. Turn these in, try to open the homework. If you can't get it open, let me know now. Otherwise, if you are finished, you can go ahead and go. And I will see you guys tomorrow. Right? Bye. See you tomorrow. Bye.
Bye, Ms. Corey.
Bye, Miss
Bye.
Corey. Thank you.
You're welcome. Bye-bye.
Bye, Ms. Corey. Thank you.
Bye. You're welcome. Everybody good? Anybody need me to go back to anything?
Bye, Miss Corey.
Thank you. Bye.
You guys good? Mateo and Brian? You still need any pages? No? Okay, perfect. All right, see you guys tomorrow. Also in this video, I'm gonna add on to the end numbers 21 and 22. So for 21 and 22, these were cubes. So we can actually go about doing this several different ways. We can use Pascal's triangle. You could also just write it 3 times, FOIL the first 2, and then distribute that answer with the third one. Or we could use the patterns. So just to show you, if we were to do number 21, and if you just take 3x plus 2 cubed, it's not that bad when it's raised to the third power. So I'm just going to write 3x plus 2, 3x plus 2, 3x plus 2. Now, when you get larger binomials, like maybe if they're raised to the 5th power, then Pascal's triangle would definitely help. But let me just go ahead and I'll just FOIL this. 9x squared. Outside gives me 6x. Inside gives me 6x. And then last gives me plus 4. I'm going to add the middle terms. 9x squared plus 12x plus 4. And now I'm going to take the third one and I'm actually going to distribute it. So let me just put it in the front so I have fewer things to distribute. So the 3 will go to all 3 things, and then I'll do the same thing with the positive 2. So 3 times 9, 27x cubed, and then it'll go to the 12x, 36x squared, and then to the 4. Now I'll distribute the positive 2, and that'll give me 18x squared, and then I'll do it to the 12, 24x, and then lastly to the 4. Now I'll go ahead and add this up, and this will end up giving me 27x cubed plus 54x squared plus 36x plus 8, and that would be your final answer. For number 22, we can do the same thing. Again, to the third power, this will be a lot faster than trying to memorize the patterns. So x minus 2, x minus 2, x minus 2. Now, if you do know the patterns for the binomial squared, you could do that. But again, remember, you can just FOIL. So if I do x times x, I get x squared. X times negative 2, negative 2x. And then now I'll do the inside, negative 2x. And then finally last, this times this. Now, I'll go ahead and write this down here. I'm going to combine the middle. So I get x squared minus 4x plus 4. And now again, I'm going to write this in the front. And now I'm just going to distribute. So x, so I'm going to distribute the x to all 3. And then I'll distribute the negative 2 to all 3. So this gives me x cubed minus 4x squared plus 4x. Then now I'm going to distribute the negative 2, negative 2x squared, positive 8x, and then negative 8. I'm going to combine my like terms, x cubed minus 6x squared plus 12x minus 8. And that's your answer there. Again, on that previous slide, you did have the patterns. However, what you would need is the row from Pascal's triangle in order to do the coefficients. So another way to do number 2 or 22 is we could also know that the coefficients from Pascal's triangle would be 1, 3, 3, 1, 3, 3, 1. And then I would use the pattern. So x minus 2 cubed. So I would take this coefficient, and then this x starts at the third power. The 2 would be at the 0, so we don't show it. And then we take the coefficient 3, make the x go down 1 exponent, and now I start counting up for the 2, it's to the first. Because before in here, let me move this over. So 1x cubed, and this would have been 2 to the 0. So remember, 2 to the 0 is just a 1. So this is just an x cubed. This just becomes, multiply this, 6x squared. But let me keep going here with the pattern. And then I still have the coefficient 3 here. And then now it's just an x, because notice I'm counting down with my exponents. The 2, however, becomes squared. It counts up. And then the last coefficient is this 1. And then now there's no longer an x because it's x to the 0. And then 2 cubed. So 1 counts up the exponents and 1 goes down. So this becomes 3x times 4. So this gives me 12x. And then here, x to the 0 is 1. So 1 times 8. So this last term is an 8. So you can either use the pattern or, again, do like I did on the previous slide. Write it 3 times, FOIL 2 at a time, and then distribute it with the third. So that's how you can work with something, a binomial raised to the third power. So that is it for P3. So now you can go ahead and complete your homework. Now, because I didn't teach this in class, number 49 in the homework, you can skip it, and then we can talk about it tomorrow in class. That's the only one that you would have needed to raise something to the third power.